All right, so this is just straight up predict the product here. So work with your and I guess anytime I say predict the product, really what I mean is you should be thinking through the mechanism, writing out a mechanism as you go. Once you've done the mechanism enough times, you're just going to be able to think, oh, product's that easy, boom, got it. Some of you might have already done enough homework to where you're there and you can just predict the product, but it always helps to think through the mechanism. Okay, so you've already paused it, you're back. What's going to happen when we mix these two substances together? So again, super strong acid. The alcohol is slightly basic. That's going to protonate. That would form OH2 plus. We have Cl minus around. We have a good leaving group. The leaving group is secondary. That means it's going to it's a weak nucleophile slash base. It's going to form a reasonable carbocation. So that's what would happen is we were going to go through a unimolecular process. That would provide us with that carbocation. We have that nucleophile right there. So what's going to happen next? So predict the product again if you haven't yet, right now. Okay. Hopefully you noticed this is a secondary carbocation. And are there more stable types of carbocations that exist? Yes, there are, right? If we did a 1,2 hydride shift here, that would move the hydrogen to that spot, which means that that spot then would have 2 hydrogens because there's one that was not drawn in there, and that would mean that the carbocation is now in a tertiary position. At that point, we have the more stable carbocation. The chlorine will add to that. One last question. Think about it. Do we need, so chlorine could add to the top, could add to the bottom. How would we represent the product or products? Are there multiple products or is it just the same thing? All right. If you put a wavy bond to chlorine, you missed a little bit, right? Because if we put the chlorine on there, is this a stereocenter? And the answer is no, right? We have a CH3 versus a CH3. That means two of the substituents are the same. That means it's not a tetrahedral stereocenter. It is just an achiral molecule. So if we put a wavy in, that indicates that we believe that it is a mixture of things, but it's not. If we put a wedge, it'd be the same molecule as if there was a dash. So that's kind of the last piece of this one, but hopefully you probably already got all those pieces right at the beginning before you even watch the video. Nice job. All right.